Hello again, everyone. We're on to the last part of what's in your water. As you move on to part 5, time for the conclusion. Figuring out from everything we've seen, what can we determine? So we do ask students to recopy the hypothesis in symbolic form. It's a good chance for you to remind them exactly what those mean, because they will have symbols in there. P equals 0.10, for example. And the big question, would you reject or fail to reject the null hypothesis, and why? Again, at this point in time, we've got some idea from a sampling distribution of why we might want to reject because of the evidence, but we really don't have any kind of numeric value. So what we do is move forward to begin getting that evidence. Based on the data provided, we'll use the ArtofStat web app. Again, you can use your own technology. We'll be able to find the probability of getting your sample proportion, or more extreme, of homes exceeding 15 ppb. That's the parts per billion, and again, it's all based on the assumption that the null hypothesis is true. We do ask students to answer one more conclusion question with circling a few pieces to help them get the language down. Let's take a look. The interpretation is really key here, especially when it comes to the p-value. So we're going to jump to the free web apps to demonstrate these ideas. Again, if you have a different software package, that's completely fine, and you'll have the ability to modify this activity as needed. Let's jump online and see what we can find using web apps. Alright, we were using the sampling distribution portion for a while, and if you scroll down just a little bit more, we'll get into inference. And the one we're looking for is inference involving a proportion. Now this is for one sample. If you're interested, you could always scroll down a little further and determine for two groups. And if you kept going, you'd have several groups. And it does include chi-squared, independence, homogeneity, and goodness of fit, as well as ANOVA if you're testing multiple means. But let's go back. So here we are with inference for a proportion. I'm going to click on that link. Now you have a couple options here. You can do confidence intervals and significance test, or find a sample size. We're going to do the one on the left. And in this situation, what I can do is choose to enter the number of successes. I can also choose to enter individual observations if I have those in a data file. So if you have, let's say, a CSV or an Excel spreadsheet, you can actually copy the observations and just paste them right here, and it'll count them up as you go. I'm going to go back to number of successes, because what I need is my sample size, which we know is 252, and my number of successes, which was 42. And I can again choose labels for success and failure. In this case, success would mean high lead levels, and failure would mean not that high. Again, kind of choosing what I see my students typing from time to time. Now you'll notice the default of this web app is to do a confidence interval, and you'll kind of see that sitting right here as we go. One piece, if nothing else, if you're looking at it, that confidence interval, the 10% that we kind of anticipated, which was our null hypothesis, it's not included in that confidence interval. So if you've already done something with confidence intervals, this might be a good time to make a connection between what we're doing now with significance test and what you may have already done with confidence intervals. But what we do is just simply click the confidence interval, and it'll give you a drop down. You can choose significance test. And now everything goes blank because in a significance test we need a little bit more information. We need the null value, which for us was 0.10. And then we need our alternative hypothesis, which for the default was looking for values that are greater than that. Now that I have those pieces put in, I can actually see the normal distribution. I can see the test statistic, which is z equals 3.528. And again, if I want to, if you choose to, you can get really deep into those calculations of the null value, standard error, and the z-test statistic. But if you're trying to get the idea down that blends in with the intuition the student might already have from what they've seen, this ties in pretty nicely. If you take a look, we have a p-value, in capital P, representing a probability. And this probability, located way out here, tells you there is not a very good chance at all that you should be seeing any values beyond that fence if the null hypothesis is true. It's a good time to review the conditional probability, the idea that this entire model is based on the null hypothesis being true. And if we assume that it's true, the chances that we would end up with values this extreme or more extreme outside that fence is 0.0002. That's 0.02%. 2 times out of 10,000 is what we should kind of be expecting. It is not likely. And you'll notice here there is not a automatic rejection line or something like that. It does allow you to put in your own significance levels. So again, if this had been a little bit closer, maybe 0.02, let's just say that it was 2%, it doesn't automatically say, oh, we reject or we don't reject. The idea here is to allow the student to make that determination based on the significance level. So it's a really great visual to help students see that the sampling distribution came back around and the results we're getting here are very similar, tied in really nicely. And we could link back to the z-distribution because we're looking at more than 3.5 standard deviations away from the mean. This should be extremely rare, and indeed that p-value says that it is. Really cool links that you could make here as a teacher. I hope you take advantage of some of those. I'm going to jump back to my PowerPoint slides. When you finish the activity, again, this is kind of introducing the idea of significance testing. You're going to go more in depth most of the time, but I would be remiss if I didn't say you could take some time and deal with some follow-up questions related to the context of this example. This impacted thousands, tens of thousands of people who had high levels of lead in their water, damage to children from high levels of lead in their blood, as well as damage to a community, extreme lack of trust of the government, and the decisions made based on economics. How much is a person's life really worth? So I hope you'll take advantage of the follow-up discussions, either in small groups or as a class. But based on the data, do you think there's a lead problem? I think now students could respond with that we've got strong evidence that there is a lead problem. But as you get deeper into it, there's a little bit more behind the scenes. The Michigan Department of Environmental Quality dismissed the Virginia tick data. Well, why could they do that? And have that conversation with your students. Yes, when you create a government and a bureaucracy, sometimes you have rules. And if the action level says one thing, which is 10% of homes at or above, but the sample must have at least half the data from worst case scenario homes, and Mark Edwards didn't do that, then people can say you didn't meet the requirements of the EPA. Would the citizens be upset when they disregarded it? I hope so. Because they didn't include at least half of the data from worst case scenario homes. We don't know what percentage were from worst case scenario homes. So it's a good chance that by not guaranteeing you have a number of worst case scenario homes, you might have had even worse data if you would have followed the EPA rule. And then a good question, what would you see? What would you want to see happen when they release the data? What information would you prefer to have? And what other questions does this raise? If you're interested, as you've already seen in the Canvas course, there are links to the Skew the Script with a very detailed Flint water crisis activity that goes through almost every topic you cover in Intro Stats. I'd encourage you to take a look at that. It includes timelines And even if you review that a little bit before you do an activity like this, you'll be a little bit more knowledgeable. You can answer a few of the student questions. You can know where to direct them for more. So I hope as well that as you continue looking and you think about moving forward with an activity like this, you have additional pieces for interested students. Hey, what about my water? What about this water that I drink at home? And you can send them to the EWG to look up their zip code and see their water system data. I put this as a tiny URL. It's just cozy-ewg. And I'll put that link in the YouTube video as well if you're interested. So the biggest piece from this is the fact that water is so critical to human life. And making determinations about whether water is safe to drink or not is something we can use a lot of statistics for. A great context, and I think your students will find it meaningful too. All right, you've got one more quiz, and then that's it for this module. Thank you again for participating. I hope you're able to take something away from it. Off you go.